answers, but I could be reading it correctly. At what angle to the forward direction would the speaker output be most difficult to hear? So there could be like a whole bunch of them, right? Because what I could do is find this angle when delta equals half lambda. I could find this angle when delta equals 3/2 lambda. And find this angle when delta equals 5/2 lambda. You get what I'm saying? That's what I'm saying. They're all the same. I mean, it'll give you different answers, but all those answers are correct because I wanted you to do this problem, but sadly the wording is a little bit. So let's just go for the first one, right? The easiest one, yeah. So if we do that, then we say what? D sine theta is equal to what? Lambda over 2. And so then, I mean, you can take it real quickly to sort of, they use this sort of approximation to say where that is.
I don't get how you get, what is that thing? I mean, that thing. What's that thing?
You mean this triangle here?
Oh, no. Like the formula?
Lambda equals FC.
Oh, lambda. I don't know how you find lambda.
Lambda equals FC.
Equals what?
FC.
Lambda equals FC.
Wait, d sine theta lambda over 2?
The solution.
On C. Yeah, it's just we use the idea that v is f lambda, right? And then we know the approximate speed of sound, which is around what? Say like 340 meters per second. I mean, you can look it up. That's fine, and whatever the approximation. So lambda is going to be v over f. So then that's going to be like around 340 divided by 500. So it's like 0.68 or something meters. So then you get theta is equal to the inverse sine of what? Lambda over 2d. And so that's going to be inverse sine of 0.34. I don't know what angle that is off the top of
It's like 20. Oh, yeah, it's 20.
my head. That makes sense because, the sine of 30 degrees is 0.5, right? So 20. Did you say 20 degrees?
Yeah.
If we look at this problem, does this part make sense?
Yeah.
Okay, there's two speakers like this, and then there's some distance d, right? And then they're saying at what angle. So like if we put these straight lines out like this, does it make sense to you that this has sort of, I don't know, I guess you could say it's symmetric? So if we find the angle for one, we also find the angle for the other. And so then what they're saying is at some angle, theta there, right, where does this become difficult to hear? And so the key for you, I mean, so did you come up with at least something like this?
Well, I don't have the speaker.
Okay. Well, let's say you went here, phi. Is that an incorrect way to look at this problem? No, because you could just come up with this after you figured out that one. Do you see what I'm saying here? Or yeah, however you graphically orient yourself, the key is not where. That's not the most important thing about the problem. The most important thing is this concept of delta. See, so they're saying, where is it the most difficult to hear? Well, most difficult, of course, occurs at destructive interference. So if you realize that it's going to be destructive interference, if you realize that there's going to be some path difference, now I can use the equation that I have in the book, which says d, or not in the book, but on the formula sheet, d sine theta is equal to m lambda. And then for destructive interference, hopefully we remember that m is n plus 1/2. So from there, I'm good. And you know what? Honestly, this problem's a little worded a little bit weird. I wanted you to think about this thing with the speakers and the cancellation and destructive interference, but the wording in that problem's a little weird.